Do it. The ominous voice has begun. Good evening. Welcome once again to Code Connectors Meetup, our big meetup that we have once a month, always on the fourth Tuesday evening. Well, at least this evening, here I am in Central Time. Really glad to have you all. The fourth Tuesday is when we have different speakers, either a single speaker or multiple speakers. So you all are privileged. Tonight we're doing lightning talks. We have 3 or 4 speakers who will be speaking on a variety of tech topics. Code Connector, for those new folks in the group, we are a tech meetup group. We roll under the umbrella of the Memphis Technology Foundation, and we're really happy to help people on their coding journeys. I'm going to drop an invite to our Slack channel down in the chat because we'd love for you to join the conversation wherever you are. If you're a brand new developer in college, boot camp, super duper 20-year senior, we love all of those different people coming together and just interacting. You can answer the daily questions, start our own conversation, jump in conversation. We have different rooms for resume review and talking about interview prep, you name it. So that's really, really cool. And throughout the month, of course, if you're on the Slack channel, you'll hear about our other meetups. We have one every month focused on UX UI. We have one where we have some fun with some whiteboard interview challenge type questions. That's once a month now on Tuesdays at lunch. And then once a month, we just get together and hang out. That's like our lunchtime hangout. So lots of opportunities. We've been doing this for 2+ years in a virtual format. I would say we're getting good at it, but that would be lying, but we're still doing it. That's the main thing. We've been consistent and we're still meeting and just getting the information out to people. So that being said, our first speaker of the evening, I don't think has made it yet. JC and I were just talking. He's in another time zone. So we're going to go straight to Brett. And what I want to do, after I introduce each of them, we want to just all turn our mics on, give them a big rousing welcome of applause, and then turn off your mics, please. That way the recording will focus in on the speaker for the Zoom. All right, so Brett is an employee of International Paper, working primarily with supply chain development teams. He has 19 years of SAP. Oh God, SAP. Yes, SAP custom application experience as an ABAP specialist, project team lead, APO analyst, and development consultant. Everybody put your hands together for Brett.
Thank you. Thanks, Lawrence. Okay, I'm going to try to share now. Okay, so my slides should be up now. This talk here is called Follow the Failing Test, covering zombies with TDD. As Lawrence mentioned, my name is Brett Rehberg. This year's our Code Connector Code Co-op Online, May 24th. Let's see, some people have cameras on if you don't, but I'm just kind of curious about what's the general experience with TDD if you're a developer. So if you can give me a thumbs up or just thumbs up icon or something if you're familiar with it, if you tried it out. All right, so now see we got some good experience. Now, what is your feeling about, do you like test-driven development? Do you use it regularly? So I'm seeing some no's, some sideways, some low questions. So yeah, definitely it's a controversial area, not really like a silver bullet methodology, but a lot of times when people get introduced to it, I feel like they're just kind of thrown in and they're not really given a lot of direction. So hopefully this talk will give you some direction to follow while you're practicing test-driven development in your own development efforts. I'll start off here with a Twitter tweet from Reactor Fiend. He says, when I don't know what unit test I gotta write next, I let zombies help me out. That's zombies. This tweet came May 12th, 2022. So this is a relevant topic. It's not really like an old technique. These zombies are new and out there today in the test-driven development world. So how does this work, right? What are we talking about? Well, you start with a rough idea of some tests that you want to do. You're going to list them out. And then this acronym zombie is an inspiration for which one to go after next. And so you code and you get that feedback loop going between your tests and your main code. And that kind of tells you what to add or remove and change in the list. Follow me so far. What are zombies? All right, ZOM is one axis of this acronym, and the BIE is the other. So along this ZOM axis, you're generally moving in this downward direction, going from 0 to 1 to many or more inputs or tests. And across the bottom axis, you're moving from your behaviors first, then you're focusing sort of on your interface ideas and how you want your API to be, and then finally working through your exceptions and handling those edge cases in your code. So overall, we want to make simple scenarios that will lead us to simple solutions as we work through these different types of tests. That's a lot of theory. Let's kind of take a look in practice. So we're going to look at an example from our Code Connector Coding Dojo meetup where the challenge was called hidden digits. And in this case, we are given a string of time in a format of hour, colon, minute, where some of the digits were actually hidden. And we wanted to return the latest valid time that we could get by replacing those hidden digits with actual numerals. The valid times would be between 0000 and 2359. So for example, if you got all question marks, 4 question marks, you'd return 2359. So everybody's kind of following along there with the idea. And there were some little business rules down here for what to do in edge cases and stuff like that. Now, the nice thing with the Coding Dojo, if you've never experienced with it, the organizers put it on, they actually provide a test suite with the challenge. So in this case, we could just run our tests to get the list started for us. Now, if you didn't have this set up, you may get out your notepad and start writing down the ideas for what tests you might have to end up actually writing yourself. In this case, we can see all our failing tests, and we just want to pick which one we attack next. I start looking through them. Right? I notice this first one returns the same time when there are no hidden digits. That sounds like a good candidate because it's hitting that 0, right? Nothing's really happening. This next one says returns latest possible time when all digits are hidden. Now, to me, that sounds like it's going to be a lot of changes, right? That's in that many and that more area. So that might not be a test to go after. And just looking down the list makes the first minutes digit 5 when hidden. So that's like one change. And so kind of we're getting an idea of where we want to start, where we might go. We're going to try to start with our first test there with no hidden digits. And then we're going to skip this one talking about all digits and attack this next zombie here. So our first test here, right, returns the time when there are no hidden digits. This is JavaScript, but it's not really that relevant to solve. The idea is that the actual value, we send 00 to our function, and we expect 00 to be returned. To implement this, the simplest thing we can do, just return the time. That'll make our test pass and get us to green. But it's not going to be very useful, right? We know going forward, we're going to want to access these digits separately. So then we'll also do our refactor step. So keeping our test green, we're going to make a small change just to split apart our digits separate and then join them back together to return. So this change in our code passes this one test, keeps this test green, but it's also setting us up for our next one. If you recall, our next one test was going to be to make the first digit of 5 when hidden. So in this case, we're getting 23 question mark 0. And the expected answer is the 2350. So again, the simplest thing I could do was just look for that particular digit. And if it's a question mark, replace it with a 5. This step, when you're trying to make the test pass, this is where you're jumping out to Stack Overflow, right? You're just getting something, pasting it in there and getting it working. You're not having to be especially clever or efficient there. And then once you've got it, you may go back later and refactor or improve the algorithm. So we got something in, it works, it passes. We'll do the same thing for another test where we want to make this one change. When we're getting 939, we would return 933 question mark. And the algorithm looks the same. We check the digit, and if the digit is a question mark, we replace it with a 9. So see what we're doing here, right? The latest minutes in our hour string would be 59. So we've independently changed to a 5 and a 9, and we've got those 2 tests passing. So great. We come back to our test list, and we try to figure out where do we go next. Again, I don't want to attack this one here because it's talking about many and all these changes. Let's try to find something else. Here we're talking about the first hour digit 2 when the second is a 3. And also the first hour digit is a 1 when the second is an 8. So looking at those two tests together, I can see it's one input for each, but there's a boundary in the values. So I'm going to focus on those two together, sort of as a pair, and implement the code to make them pass. So for the first one, we can use the same approach we've been using of checking that first digit, and if it's a question mark, we'll just replace it with a 2. So to make this test pass, right, we now replace the question mark over here, if it's a question mark, with a 2, and we get 2305, our test passes. Then we look at the next test. Oops, excuse me. Now this one's going to get a little tricky because we have that boundary value, right? There's multiple paths with this single input. If we just came and changed the digit here to be a 1, right? Yes, this test would pass and our other test would fail. So we're going to have to do something a little more clever. Here we stick in what's called a ternary operator. And this is just saying if the next digit is greater than a 3, then use a 1. Right? That's because 23 is our highest hour. So if the digit here is less than a 3 or less, then we'd have a 2. But if it's more, we can only use a 1. Right? So 14, you can't have 24 or 25, that's outside of our range. So we need to have 14 or 15. And then passes this piece of code. And finally, we do something very similar for our other one. It's just the second digit, we're the same thing. We first stick in our chunk of code to replace a question mark with a 3. So if this digit here is a question, replace with a 3. And then we do the same sort of path. In this case, saying if the digit is less than a 2, then it must be a 9. So if we have that 0 or 1, we can go all the way up to 9. But if our first digit of our hour is a 2, the max we can have is a 3. We can only go up to 23. We run our tests again, and they all passed. And look at that. We even got a bonus one. So while we were working through solving those other tests, the changes, the code we implemented, actually passed our original tests. I'm running a little long here, so I'll go quickly through these last two. Now we're coming to our error conditions. For one of them, we didn't have enough digits, and our logic was working. It was making replacements, but that's not what we wanted. We should have actually returned a null string. So we just add in a guard clause here to check the length of our digits, return null. And finally, it's possible there's extra white space in our interface. So there's a interface concern. And to handle that, we can just trim our string before we split it. And this trim space statement will chop off that and move us forward. Okay, so that was a lot there, right? I solved through, write all this code, passed all 9, 10 tests. Our test suite's looking good, right? Followed our zombies, they let us through. But if we had started off with maybe the second test, it would have led us to write a whole lot more code that we wouldn't be testing as we were going. So by picking the individual ones, we're testing as we go. And I'll wrap it up with a couple more quotes from Reactor Fiend here from Twitter, where he just spells out the zombie acronym. 0 for the 0 null input. It can also, like you noticed, our 0 input was just 0, 0, colon, 0, 0. So it's whatever is the initial value as well. And when you're doing object-oriented programming, you might also be checking just the creation and the destruction of your objects and seeing, are they instantiated properly? Then you move on to your one input, or maybe one object under test, and then move on with multiple different inputs, or maybe instantiating multiple objects in a collection or something like that. And on the other axis, we have our BIE letters for our boundary behaviors, our ideal interface, and our exercising exceptions. Overall, we want to keep it simple, simple scenarios leading to a simple solution. That is the end for my talk. There's a reference. You Google this Agile Alliance link to see the original article written by James Greening. There's a couple of Twitter things for folks to check out, Code Connector.
Awesome. Nice work. +1 for the Code Connector Coding Dojo plug. I love that. I couldn't have asked for any better. Awesome. So what we're going to do, everyone, in the interest of time, we'll take up to 3 questions per speaker. If you have time, Brett, or if you can stick around for 3 questions, just first come, first serve. So anyone who would like a question for Brett, just jump on in there.
Yes, I got a question. Are there any really good resources for TDD?
I think the best resource really is just going through it. And so what I did was actually looked at the original book by Kent Beck, TDD by Example, where he goes through a problem step by step, and I re-implemented that in a different language. But I really think it's something you've got to get your hands dirty with. You can't just watch it. So finding a tutorial or something to follow along with would be the way to do it. And just trying it really on your own exercises, because a lot of the issues that you run into with TDD, they don't really make sense until you experience them yourself. You have to hit those pain points and then become used to them and see the benefits. It's really hard to evangelize about it. But you know, I like being able to refactor and change my code in my environment as a enterprise programmer. Right? Our code isn't static. As our business environment changes, we need to make changes for things. So we're going to have to go back and adjust the code, and we don't want to break our existing functionality. So there, the having the test in place are a big benefit for me. But until you've had to go back and change something and seen it break and scratched your head, you don't really. You got to make the mistakes to really feel the benefit.
Other questions for Brett? Just not all at once. We don't want to overwhelm them.
Brett, sorry, I was scrambling for the mute button. Brett, have you watched any of Dave Farley's videos on YouTube where he talks about TDD?
Yes, I would have trouble picking out a specific one. If remember, yeah, I've seen several of his very interesting, and the continue integration stuff, and
yeah,
it's really, I think it's really big to build up that pipeline to have those tests in place and that kind of thing. And so again, like there's a benefit downstream of the tests, even though you might not see it when you're doing the TDD, but having that test suite in place, it's just, at first you kind of have to take it on faith, I think.
All right. Any last questions for Brett? All right. If not, Brett, thank you so much for coming in and dropping the TDD wisdom on us. As much as we may go kicking and screaming against it, it actually does have value, and thanks for highlighting that. From now, we're going to kind of slide tangentially from that into more of an agile and product methodology, that kind of thing. So we're going to have Steve Hallman coming up next. Go ahead and turn your mics back on to give him a round of applause in a minute. Steve Hallman is a longtime operations management practitioner and agile coach. He's been featured on Adobe software site, BBC Business Daily, and coach teams in Fortune 500 companies like FIS and the Walt Disney Attractions Technology. Everyone give it up for Steve Hallman.
Thank you. Thank you. Do I sound good and look okay?
10-10, Steve.
All right, good deal. I'm going to share screen here, and I think I want that one. All right. And of course, Zoom changes everything when I do that, so I got to move everything back around to get comfortable again. All right, there we go. All right. I have not timed this, so this will be interesting. I asked people, of all the things that you hear me rant about in the Code Connector Slack, what would you like me to focus on? And this is what I got. So I'm going to try to run through this. A lot of what I do when I teach Scrum and Agile is start with Frederick Taylor somewhere around the year 1912 and go all the way through Gantt and PERT and Deming and total quality management and lean and Japanese OM techniques, all the way up to today, and how those turned into agile and lean techniques that we use in the software world. So it's one of my favorite topics to delve into that. And then somebody asked me about something I've been working on the past, I don't know, maybe 6 months or so. How do you make change when you have tightly coupled systems in people, just the same way that you can have tightly coupled systems in software, right? So I'm going to try to tackle those two things. And this is going to be a fire hose, so just hang tight. So Frederick Taylor is awesome in the same way that Sigmund Freud was. We don't do a lot of psychology the way Freud did, but he kind of got us started. And Frederick Taylor is the same way. Frederick Taylor turned management into a science. And in 1912, if you worked in a factory stamping metal pieces, that was really good for you. Frederick Taylor's worth researching. He turned management into a science, but we're not in that context anymore of simple, repetitive physical labor that your boss does the exact same way and his boss did the exact same way before him. So custom software development is brain work. It's complex, it's uncertain, information emerges daily, things are always changing. So that 110 years of operations management science has gotten us up to like superpowered computers doing discrete event simulations overnight, where they're running like hundreds of millions of iterations of a problem, things like that. But all of those sciences don't apply in the custom software world. So how do we filter out what things work in a factory setting, what things work only in the world of custom software development? How do we tell the difference? And what do we do with those three categories? So what happens if we use techniques that no longer apply? The simple answer to that is that they're not just neutral. If you try to apply factory techniques in a custom software development world, you'll actually make things worse. They're not cost-free. So my little note in the corner there, science deprecates just like software does, so make sure you're using the latest version. So one of the problems that we have is managers are often tempted to use older metrics that go back several hundred years, and people have a tendency to want to be measured by those metrics. So it's kind of a bootleggers and Baptists conglomeration where two people are cooperating on something for different reasons. And as I said, when I'm teaching this, I kind of go through this long piece of factory science, and eventually this little noise start like a little violin. It starts, this tension is gaining in the room, and somebody will eventually raise their hand and say, wait a minute, we're not a factory, which is awesome. That's good. I want people to point that out. So here on out, as we work on this project, I don't want anybody telling me that they want to be measured by factory metrics, right? If you're going to tell me we're not in a factory and we're smart, pink, soft human beings making incredibly complex software, then you aren't allowed to fall back on those rules either. So why do people like those metrics? Because they're easy to measure. It's like the joke where the person's looking for his wedding ring on the street under the street lamp, and somebody stops by and hears his story and says, so you dropped it around here? He said, no, I dropped it over there near that gutter, but the light is better here. So, you know, sometimes we look at metrics because they're easy to measure, right? So hours worked, stories that we have in progress, you know, things that encourage multitasking, focus on speed, focus on resource utilization, where when they say resource, what they mean is you, people, efficiency. And there's a lot of confusion about what is an input and what is an output and what is an outcome, right? So lines of code are just an input. Lines of code give you some kind of a status check, like what are you working on? And you say, well, I'm busy on this thing, or I'm blocked on this thing. That's an output, but I can't sell that to anybody. When a user clicks a button and they're able to find a date on Tinder, that's an outcome. That's delivering an actual piece of value to somebody. And that's what's really important. One of the reasons metrics are not important is to find a way to cast blame on people, right? So as we start getting further into a project and people start falling back on this kind of factory mentality, I have to break out my Andre 3000 and say, y'all don't want to hear me, you just want to dance, right? So I'm going to harp on this factory thing. You're going to hear it from me over and over again. So I want to talk about a heuristic in the factory world, or that goes back in operations management science, and is kind of the mother of all bad metrics. So there's something called the greedy heuristic, and it's a way that lots of different OM or supply chain problems are solved. So you may have, say, a grid of suppliers of different types of furniture, and then on the other axis, warehouses that want to receive those types of furniture. And you can just go, I'm going to take as many chairs as I can from this first one until I'm full, and then I move on to the next one and so forth, right? It's not necessarily the most optimal way to distribute pieces of furniture from one type of location to the other type of location. It's just a simple way, and it will get the job done. So if you think of the greedy heuristic as an algorithm, it's this basic format. You've got some kind of Y, your vertical axis, that you're trying to increase: throughput, money, what have you. So we're going to increase X, which is any of the levers that we have to push to make things happen. So as long as we increase X and Y keeps going up, then we repeat, increase X some more. Let's see if it goes up, increase X some more, see if it goes up. Once you've increased X and your Y starts to go down, then you back up a step and you've found your optima. And if you see the little picture up in the top there, you see what I mean, right? You're going to go back and forth until you find where your X gets you a maximum output. The problem there is that not every problem can be solved this way. You can't take 9 pregnant women and make a baby in a month. There's other problems that go along with this. The chief one of which is that we may be looking at the wrong sense of scale. So if you look at that local optima up there, I'm going to skip through some things here real quick. 110-year-old management based on the assumption increase X outputs, so more people, more hours, more story points, more speed, resource utilization, efficiency, etc. It all adds up to more work in the system, right? So the problem is scale. You can get trapped in areas of local optima, which keep you from finding your total global optima. And in a realistic scenario where you've got more than 3 or 4 inputs, those spaces, those solution spaces can get really complicated. Once you go beyond 3 dimensions, you can't even model it in a visual way. You just have to do the math. So how do we use heuristics but not fall into traps like the greedy heuristic? We have to have some way to figure out what works for factories, what works for software that doesn't work for factories, and what are things that work for both, okay? So for things that are factory only, use the heuristics, use the model, but lose the specifics, things that don't apply to direct factory work. If it's a technique that works for both, just use it as is. If it's a technique for software that gives you something that you can't do in a factory setting, exploit the heck out of it. That's where you're going to make your money. Those kinds of techniques are the reason that teams can get things like 200%, 400%, 800% increases in throughput or value. So how do we know? How do we know which ones we can use and which we can't? I can't give you an easy answer on that. I'm working on a long-term project to try to catalog all these techniques and sort them out, but these are some simple rules. If it's replication, it's hard to change later. That's more likely to be factory. The primary thing in software is it like clay rather than concrete, because software can be divided up into thin slices. I can give somebody a tiny piece of value, and if you add more pieces, you can start sticking them together and make a bigger thing that produces value. Now, Lawrence, I'm noticing I'm already at the 10-minute mark. What do you want to do? Do you want to kick me off, or you want me to just run with it?
You're rocking and rolling, man. We think about another 5 to 10, give or take.
Yeah, sounds good to me.
Rock and roll, man. You're good.
All right, cool. So this is an exercise and a great way to think about this. I did this with my team. I can send you instructions, kind of offline on how to work something like this. And it gets people thinking about types of problems and unique things that you can do in the software world that you can't do in the physical. So in going through this idea of cataloging techniques that are available, I think I've kind of come to the conclusion there's only about 9 techniques in the entire world that make things better. I could be wrong. I'm still distilling, and I kind of cheat because I'm throwing all the acronym things on the bottom here. But these 9 techniques do everything empirical. Make decisions based on data that you have from the past. It's okay to forecast and experiment, but make those as small as possible and as cheap as possible. Order everything by value, work on one thing at a time, use a pull-based workflow, make your batch sizes smaller, which means in the software world, make those stories smaller, smaller, smaller. If the title of your user story has the word "and" in it, it's not small enough. Shift quality to the left, which is what we just heard about. Use patterns, automate anything that you can automate. If people don't want a mob or they don't want a pair program and they say, this is just a one developer task, it's just one person, it's going to take me less than a day. Awesome, then automate it. Quit telling me something so simple that one person can work on it. If it's that simple, then make it a robot. Continuous integration, continuous deployment, behavior-driven development, test-driven development, acceptance test-driven development, trunk-based development, and TCR. If you do those things, you will win. That's my guarantee. The warnings against some of these anti-patterns: multitasking is garbage. There's no such thing. You're not multitasking. You're doing 2 things shittily, right? Context switching. If you're jumping back and forth between 2 different types of work, it kills the flow of work and it kills your flow state in your head. It messes with your psychology. There's actually studies in the past couple of years that working on more than 2 things at a time, context switching, drops your IQ somewhere in the neighborhood of 12 to 15 points temporarily, right? It literally makes you dumber. All right, skipping forward. So there's all these great techniques. Well, that's awesome. How can I actually use those, right? Because I live in the real world and I got a real boss and he's a jerk and he won't let me do anything. So how do we make change in that kind of world, right? It helps if you smile and I'll point at the same thing on the table like the stock photography people. So if I have a tightly coupled system and we can't change this thing because we got this kind of database, but we can't change the database because we got this API that's calling it, what do you do in that situation? I love this quote. I've tried to research it. I cannot find where it came from, but I heard it from somebody. Don't live in the problem, live in the solution. That's your motto. That's what I want you to think about. All of the objections that developers raise against using modern software development techniques, some of these have been around 23 years, right? TDD is not new. They all come down to our metrics are set up to incentivize us doing the wrong thing, or we can't replace this anti-pattern with a better thing because it's dependent on some other anti-pattern that we're also doing. So remember I said you all have to point at the same thing? I wasn't kidding. That's really literally how you make change. This is another exercise that I recommend doing. If you're interested in this, I've got a way to turn this into actually 4 different things that explore not only goals, but what are your anti-goals and what are your not goals and how to focus goals. So hitting this at a really quick level, companies have goals and they're things like, we're going to make the best car we can so that we can get the most revenue possible. Simple, straightforward, right? Your department, and you might have multiple, maybe you have an IT department and your customer department potentially, or it could be singular. And then at the individual level, you're going to have conditions, right? So goals, mechanisms, conditions. Get everybody together, whoever is your closest person to corporate, whoever represents your department, all of the people in your team, and get on the same page with this stuff. Write what these things are all about, because if you don't believe that Disney World exists, you will not get in the car and drive to it, right? Now, Walt Disney could see 2 kingdoms on either coast when other people could just see orange groves and swamps, right? But once a thing is built and Google and Netflix and Flickr and YouTube and Facebook are releasing code every 10 minutes, there's no technical reason that you can't also be releasing code every 10 minutes. It's simply the decision to believe it's working for other people. They're no smarter or better looking than we are. We can do it too. Once you do that, you've got goal alignment. You need to prepare people for the worst. I'm not going to dive into this really technical looking diagram, but the bigger the change that you want, the bigger the dip before you get there. In some teams that I work with, I would advise bringing everything to a grinding halt and pick one story and work on that story as a team until we get that thing into prod. There's lots of different levels of doing this. Sometimes you can try to fix the airplane while it's running down the runway. That's not usually the best, but somewhere in between, you have to accept that you're going to take a loss to get some kind of a change in improvement, not simply a level shift up, but a change in the slope. If you want to do that, there's going to be a little bit of pain up front. That's, as I said, how teams can get things like 200%, 400%, 800%. This is a team that I worked with. The previous 2 years looked exactly like what you see on the left-hand side. They thought that they were pretty good, hovering somewhere in the 50 to 100 point range. When I left them, they had increased their throughput by 1,600%. So how do we do that? You do the exact same thing you would do in software. You do branching by abstraction. If you have a service that pulls data from another service, think of it like a waiter getting a dish from the kitchen. Well, you put a table in between those two. The kitchen serves the table. The waiters pick things up from the table. Then you can change out your pizza oven for a barbecue grill. You could rotate the kitchen out and bring a whole new kitchen in. It won't matter to the waiter because he can get his dish off the table, right? That's what you would do in the software world. You do that as much as you can with process and people and anything that you want to change in your system. So try to have the bravery to map what you actually do and what you have, not what's written in your manual, not what's in the poster on the wall, not what you claim your practices are, but describe and draw it out as a picture. How do we actually operate? How do things move through our system? And just put the warts and all out there, right? That's your current factory. And then you want to ask yourself, where do we want to be? And get specific, not we want seek times to be faster, but we want a MongoDB that can deliver this kind of a performance rate, right? You need to describe exactly what those pieces look like in the new blueprint that you want to go to. The reason we do all this is that humans have a tendency to default to the status quo. When we have tightly coupled things, sometimes it's 3 things, sometimes you're going to have this pentagon of 5 things or more. It's really easy for people to use all the other things that haven't changed yet or can't change yet as the excuse not to change one thing. So we want to stretch this imaginary rubber band between each piece of our current system to the new model. We want all of the tension to be snapping us to the future model, not snapping back to the status quo of what we have. And then when you're able to break one of those little triangles or one of those little squares or one of those little pentagons, then move that one piece to the new system. Some of the complaints you're going to get are, well, now our metrics look like garbage. That's going to happen. Whatever. There's going to be various things. They say, well, what's the point in changing this? Because it's not going to pay off without changing this other thing. It doesn't matter. That's not what we care about. What we care about is breaking the pieces and moving them to the new system, because eventually you will be able to move that other thing. And then once those 2 pieces are in the new system, then you will get the payoff. And the beautiful thing is you get to cheat at the very end. Once you get down to the last 2 pieces that haven't moved, there's no reason to stop one of them. You can move both of the last pieces together at the same time. One of the ways you can get managers and executives there is give them better metrics than the crappy metrics from 110 years ago. What do we really care about? So this is where I'm going to bring this airplane in. Dollar value. Every single thing that you work on, put a dollar value on it. If you can't figure out how to handle streams of cash flow versus one big sale and things like that, you can do net present value. You can calculate a cost of delay for every single thing that's in your backlog. You can say, for every week that we don't do this, or every 2 weeks that we don't do this, it costs us X amount of dollars. Suddenly, technical debt and user stories and all of these things are on an equal footing, right? It simply comes down to dollars. Deployment frequency. How often do you ship? That is number one. Lead time or cycle time. How long does it take Bob's hot new idea to get in front of his face that he can actually use it in a production system? Measure that and constantly work to bring that down. Mean time to recover. If you do TCR, that's your model. If prod goes down, how long does it take you to get prod working again? If you're just restoring to the last good prod, this should be like 5 minutes, 10 minutes at the most, right? And then change failure rate. Bug rates are meaningless. Bug rates are stupid. You could make 100 bugs in one release and it just brings prod down once. Who cares? Who cares what the rate of bugs is? You might put out 100 pieces of software every 2 weeks and only have a bug rate of 1%, which sounds really low. But if that bug takes prod down every time you release, it doesn't matter that your bug rate is 1%. Every time you release, you're taking prod down. What we care about is what's your change failure rate. Out of the numbers of times that we ship code to prod, what proportion of those take prod down? And then work on constantly reducing that. That is it. That's my time. I doubled my 10 minutes. This is the way. If you do these things, I promise you they work.
Wow. Darn you, Steve. As much as I tried to resist, I drank the Agile Kool-Aid tonight in 20 minutes. All right, you all, we're going to take up to 3 questions from Mr. Steve Hallman, who hails from Birmingham, right, Steve? He's in Birmingham?
That's right. Yes, sir.
Awesome. So you guys, first come, first serve. Any questions for Steve? I see a hand from Coriano from San Diego. People from all over the place checking in the Code Connector. Go ahead, Coriano.
Hey, definitely. So yeah, Steve, I appreciate this. You mentioned about during the talk about focusing on one task at a time, or kind of like completing one ticket to production. With my current team, that's the challenge I'm facing. Is our stakeholders, everybody wants us to get things to testing as quickly as possible, and our team is doing that. But what's happening is our team is getting finished, pushing it to testing, and then getting new tickets. And testing hasn't had a chance to test to see if there's any bugs and things. And sometimes, or I would say quite often, by the time testing's able to test that, they find some bugs. So then they're creating that ticket, and then they're wanting us to try to see if we can fix those bugs within the same sprint. But the reason I kind of mentioned that is because I talked with my PM about that, where I told him I wasn't comfortable bringing any new tickets in until testing at least looks at 2 of my tickets. So I had 4 tickets that were pushed to testing. I didn't want to add in a 5th ticket until at least 2 of those tickets were moving forward. So he was okay with that, but it was something, like I said, that I had to address and kind of speak up about. That's something that I wasn't comfortable bringing in until at least a couple of those tickets were moved forward.
So is my screen share still working? I tried to hit the screen share, but I don't know. Okay, I don't have the border anymore. Okay, you guys see the graphs there with the red and blue stuff?
Yes.
Okay, this is an exercise. Of course, I can send you the link when we get back on the Code Connector Slack. But I've done this exercise with a manager who it was like arguing with, I don't know, Scrooge or something. He just was literally the worst, right? Anything you can imagine. He was stubborn and hard-headed and was not a technical guy. And I did this exercise, and in the exercise, you have 2 people be developers, and they're serving 5 people that are companies that need things developed. And I made him one of the developers, and we went through this exercise. And if you try to do 5 things in rotation, or try to do 5 things by doing them one at a time and completing them, This is the difference that you can see in time. This is the exact same task, just being done rotationally versus one at a time. The shortest time that the fastest person got done is longer than the longest task that the slowest person did in round 2 when they're doing things one at a time, right? I can show you how to do this with your team. This is mathematically inescapable. This is due to something called Little's Law. You can't violate it. There's no way around it. My guess, just from hearing what you describe, I mean, I'd have to dig in and ask more questions, but I'm betting that your stories or PBIs, work items, whatever you call them, are probably pretty long, or probably pretty big, I should say. How long would you say on average it takes to produce, one widget, the things that you guys work on? What's your average time to picking it up to code complete?
I guess we could kind of go off of our new feature. I would say lately it's probably taken, let's say, like creating a form, just creating the form, putting the label and stuff like that, getting that would probably take 3 days, maybe 4 to actually get into the done column.
Okay, so that's not bad. This is going to sound crazy, but I would tell you to split every story until it's 1 day of work. And the longest it should be is if you're shooting for a day and it ends up being 2, right? I know that sounds hard to do, but if you imagine a feature like, I want to push a green button and have a GIF of either a clown or a shark or whatever, some kind of character pop up, and it's going to say happy birthday. It's going to pull my birthday from a database. It's going to make some kind of GIF and a noise, something like that, and then tell me like a relevant thing that happened on my birthday. That's about 9 different stories, right? You can take each of those individual things and make a raw hypertext link that makes that GIF show up. And that's it. Make that and push it to production. That doesn't take a day. That takes about an hour. Then add the next thing to it. Then add the next thing to it. It's about understanding how to architect your software in a way that you get used to producing the thinnest possible thing that produces value through the entire software stack, and then incrementally adding robustness to it. And you should have a QA person involved the entire time you're working on it, right? So if QA doesn't get your thing until you're finished with it, you're still just doing a waterfall. You're still just, we have a stage and then we hand it over to you and it's your stage. They could be writing tests while you're still producing the software. In fact, they could be writing tests before you produce the software. So there's a lot of different ways to solve that.
Thank you. Appreciate it.
All right, and we'll take up to one more question for Steve Hallman, if there's any. You blew him away with the graphs, man. You started pulling out the graphs, and it was just like,
boom.
Maybe not a question, but just more wanted to hear your thoughts. The SAP space, they commonly push running SAP like a factory. Like this is actually a thing they promote.
Mm-hmm.
Run your software like a factory.
Mm-hmm.
And so the managers buy into that concept. What would you say to somebody to explain how that's not a good idea? Right? It seems like that's not the page you're on.
Yeah, it's a weird thing. So I even find myself going back to the factory metaphor a lot. And it's good at a metaphorical level, right? The difficulty is stories that we think are going to be a day might turn out to be 7, right? Or we think we're going to work on item number 2, but then the product owner comes screaming in at the last minute with, oh, there's this hot thing we got to fix, right? That doesn't happen in a factory. So Toyota can produce the exact same car every time, every 93 seconds, because nothing is left to chance. So when I say use the heuristics and throw away the specifics, That's what I mean, is you can kind of create a factory, a software factory to some degree. You just have to keep in mind that there's complexity, variance, all of those things. And the best way to work those down is slicing. That is the one thing that will get essentially everything down to a nugget of one day's worth of work. And if you can do that and get good at that, you'll figure out what your throughput is. You don't need to estimate anything anymore because everything's a one. And then you're just going through how many ones can we fit in our shopping cart each time you do sprint planning, right? So I love metaphors, and sometimes I'm jumping from air traffic control on an aircraft carrier to, you turn into a hockey goalie in the same sentence, and I've mixed my metaphors up. So software as a factory or production as a factory can be useful, and it can be a good way to draw things out. But we shouldn't use tools that don't apply to the current context that we're in, or steer us in the wrong direction from the things that we actually want.
Fantastic. Well, thank you so much for that, Steve. And again, for the graphs, for sure. I'll be going back to these on the YouTube, make sure I can read them all because some of the font's just a little bit small for our eyes, but fantastic talk. I appreciate that. And I know the group does as well. So I do not see a Grit. I hope he's okay and things are going well. I'll just blame it on the time zone. Maybe there was a mix up, but we're going to go on to our third and final speaker. I'm sure he's wondering why I didn't ask for his bio like I asked for everyone else's. And the reason is because I have my own words that I wanted to put on this for the next speaker we have, which is Joe Ferguson. Joe Ferguson, you guys see him in the corner there. He is a friend and mentor here in the Memphis, Tennessee area. The running joke is he's PHP famous, and what makes that funny is it's actually true. The contribution he's made to the language of PHP and in the Laravel in particular. But probably much more important to me, the reason I'm a fanboy of Joe Ferguson is his example of being a very open, honest, and empathetic person in the tech space, and just an example of a decent human being. Now, sometimes depending on what circles you circulate in, sometimes those are hard to find, or maybe they'll have like 1 out of 3 or 2 out of 3, but generally speaking, time after time, and I watch his example in a really passive way. I don't say, hey, let's sit down for a chat. I just watch how he operates, and he likes getting things done, which means a lot to me. So if you all would, take a second, turn on your mics, and want to just make a bunch of crazy, ridiculous, thunderous noise and round of applause for my friend and mentor from here in Memphis, Tennessee. I said already, Joe Ferguson.
Thank you. Hopefully you can share my screen. I'm doing a weird thing and Zoom's being a little weird. So give me a thumbs up if you can share, if you can see the screen and it looks okay. We're going to talk about Ansible and specifically modern infrastructure as code with Ansible and what that really means and what that gets you. Infrastructure as code sounds like some just made up words, and you're not necessarily wrong. It is kind of weird, and it goes along with the thing called DevOps. If you've been experienced or if you've had any exposure to any DevOps systems or platforms, Ansible and infrastructure as code is a large part of what brings those systems together and how they work. A quick little bit about me. I'm a principal software engineer at a company called Pretect. We're local to Memphis. We put computers in truck engines and tell you when they blow up. Hopefully we tell you before they blow up. I wrote a book on Windows subsystem for Linux. If you're a Linux geek and a Windows nerd, check that out. I'm a football fan, hockey, and race car nerd. So if you're in any of those things, feel free to reach out and we can trade horror stories and favorite teams and whatnot. So for further reading, if you're interested in Ansible, there's no way I'm going to cover everything in Ansible, but this book does cover just about everything with Ansible. It's written by a guy named Jeff Gerling. I've met him a couple of times in real life at conferences on the PHP community. He is super awesome and super knowledgeable. He also writes tons and tons of Ansible that you can go and run on your own projects and your own servers for free. It's open source playbooks is what they are. And Jeff goes out there and creates playbooks for different distributions. He is a big part of the Drupal community, or he has a lot of involvement in the Drupal community. So a lot of his playbooks for PHP are focused around serving and maintaining Drupal sites. So what is Ansible? Ansible is a Python app that is essentially in charge of running tasks on a remote system. How you get Ansible is just like any other Python library, you can just pip install it. If you're not a Python expert, then there is a couple of other ways of getting it, but essentially you want to pip install it. It is the cleanest way of getting Ansible. Now, Ansible, the Python application, is broken into 3 different components. We have modules, and modules are, think of them like they could be a Python library or a JavaScript library. Ansible modules are almost all written in Python. These are units that perform a task. Like a module would be something that installs SSH and configures a user to use SSH. Or something like installing a web server and configuring a site. You would have a module that would perform those tasks in a specific order. The second component would be inventory configuration. This is your declaration of your target systems that you're going to be acting on. Ansible works over SSH, so everything is managed with SSH keys, which means there is nothing to install on a remote computer to get it to work with Ansible. Everything is already installed as long as you have some Python libraries on the client system and it's a recent distribution. The third component are playbooks. Playbooks are a complete set of roles and actions. Playbooks are a unified set of tasks and modules that make a thing happen. You would have a playbook that configures a server to your specifications. Now that may involve installing Python. It may be involve installing PHP or Ruby. It would be responsible for creating the web server configuration, whether that's Apache or Nginx. It would configure any other services you needed on your server. So if you were building a playbook to install a web server and configure a website to be hosted there, you'd have to do a lot of different things. And Ansible allows you to do this in YAML in an explicit declarative ability. Now, if you hear me say YAML and you cringe, turn on your white space indicators in your editor. That will greatly help you understand what YAML is doing. It is white space sensitive, so you do kind of have to deal with that, but turn on your white space indicators in your editor and it will make it a lot easier to see what Ansible is doing. So the module, or an example of a module in Ansible, the most common one is the command module. This module will execute a Linux command on the remote system. So what is the module capable of doing? Well, it's capable of doing a whole lot. So what you do is you describe in YAML that you want to run this module and you fill in the fields. Now, if you need it to run in a certain folder first, you can use the chdr, the change directory. You specify the command. If a file gets created, the module can make sure that that file will get created after it runs. And if something happens and the file doesn't get created, the task will fail, alerting you to, hey, something is going wrong. So some examples of the command module. The first one there, we're just going to cat the message of the day on the system, and we're going to read that contents of that file into a variable. So we just say register, and that's how we can create dynamic variables. So if we need to know something on the remote system, we can read it into a variable and then read that variable or use that variable later. The second command, we can run a command if a path to the database does not exist. So what we're going to do here is just run a make database command that has a couple of parameters. And we use creates there to only run this if the path already exists. So that way you don't have to create folders that already exist and fail if that was a command. Because we're using the command module, Ansible is capable of detecting failures for you and reacting based on what those failures are. We can use this creates. We can also turn off failures if we know something is going to be flaky, and sometimes it's going to work, sometimes it's not. We can say warn, on failure, do nothing, so where it can still run. That's kind of fragile and not a great thing to do, but that's kind of what you get when you start out with Ansible, because the command module is where people start to do most things with Ansible. And what people don't realize, or what we will realize shortly after getting into Ansible, into the ecosystem, is that it's not just about the command modules. You're not just running commands like you're writing a shell script to do all of these things. There's other Ansible modules that wrap things like configuring email servers, creating SSH keys, creating users. There's modules for different Linux distributions out there that are already bundled into Ansible that allow you to run and use these modules regardless of the underlying system. In some cases, Ansible is smart enough to realize if you're on Unix or Linux or Mac. In more cases, when you are in a multi-operating system environment, you can actually configure that into your playbooks to where you're only going to run specific things on specific hosts. Like you don't need to install Homebrew on a Windows system. So you could have that set up in your playbooks. If you're deploying a Mac, you want to install Homebrew on it, you can have a task and a playbook that will install Homebrew for you, but you don't want to try to run that on a Windows system. So you can look at the operating system in Ansible during the runtime and see what it's capable of and what it could be used. And you can also tag all of your own assets to do this as well, to where you could be able to see, is this a web server? Is this a database server? Is this a proxy server, and that sort of thing. So you can treat your infrastructure differently. Now, this is an example, a very, very basic example of a playbook. And an Ansible playbook is a YAML file. In this example, it's that vagrant.yaml file in the root of the project. It is the playbook is the middle file there where it says configure vagrant. The top file is the inventory file. What we've done is we have created one host called default, and it's dedicated its IP, and we've set its IP to 1.13. And then we have set a variable for our system user in our inventory file. This is just an example of where you can put variables in Ansible. You can put them in many different locations. So many different locations, there's actually a priority order that when you start doing a lot of Ansible that you have to get really familiar with on how variables get overridden, because I kid you not, you could put variables in Ansible just about anywhere. So you have to be a little bit disciplined in where you're putting your variables and how you're accessing your variables. The very bottom is an example of a task, this vagrant.yaml task. It is going to install Vim. And we have plugged this task into a role called install Vim. So up on the left-hand side, you can see we have a roles folder and we have install-vim. And then in that role folder, there is task. This folder structure and this layout is very explicit to what Ansible expects. So as long as you follow the rules, everything will work. And what are the rules? Well, the rules are all in the documentation. The documentation for Ansible is really, really fantastic. So an example of a module, we're using the apt module in the bottom file there. We're saying name, we're going to install Vim. We're naming our task. We're passing a package value of Vim to the apt module, and we're also passing a state to be present. What this translates to is the apt module will look in and Ansible will say, all right, apt module, we want to install Vim and it needs to be present. And the module is smart enough to not install Vim if it's already been installed, because it can look at the system and say, oh, well, Vim's already installed. There's nothing for us to do. It'll just exit out saying there's nothing to do. We're done. Or if Vim isn't present, it can install Vim for us automatically. So Ansible is also idempotent in that you can run these tasks over and over and over, and you're not going to have a negative impact on the system. So if you wanted to just write a shell script that installed Vim, you would just run that shell script and it would install Vim and tell you that it was already installed every single time that you ran the script, right? That's not that is an idempotent script. It is going to run without affecting the system, but the better aspect is if you don't need to install the package, don't do anything. And that's what the apt module does. And that's what Ansible modules do by default, is they all only take action if they have to take the action. If the action has already been done, or if the state that you're describing in your playbooks has already been applied or is the current state, nothing needs to be done. So think of Ansible as a way to apply state that is documented in your playbooks to a running Linux system. We can run our Ansible playbook from the command line. We use the Ansible playbook command. We pass in our playbook, which is our vagrant.yaml, and we can pass in an inventory file. So what we can see here is I ran this on my local host and it installed, didn't need to do anything. So it's green. So Vim is already installed. Now, if you want to get a little bit more complicated, let's go get an Ansible role from Ansible Galaxy, which is one of the locations that you can go. It's like the GitHub for Ansible roles. That's where you go and you can discover roles that people have put up that are open source and that you can reuse. This is one that I pulled into a project so I could actually show you the project structure. We have defaults, which are all the default variables. We have handlers, there's meta, there's multiple tasks. and there's multiple templates. This is a really good breakdown of an Ansible playbook that's designed to be run against Debian and Red Hat Linux systems. So if you're not familiar, Debian systems are RPM, or not RPM, they're deb package based, and Red Hat is an RPM based system. So the different package managers, you can't necessarily just take a Ubuntu or Debian deb file and install it onto an RPM system. It doesn't really work that way. So there are situations in Ansible where you can completely divert the execution based on the operating system. That's what we're doing. So when this task runs, it runs main.yaml. And in that main.yaml, there is a condition to where if the remote operating system is Debian, it will run the setup Debian YAML script. And if it's Red Hat or Red Hat derivative, it will run the Red Hat version. So this is how you can build and support multiple operating systems into your playbooks. And as you can see, the templates are all J2 files. These are Jinja templates, which if you've ever done anything with Django or a Smarty kind of based templating system or a rudimentary templating system, you should feel right at home. It's very, very similar. It feels very basic as for a templating library. On the top right here, we have a configuration file where I've actually am using some of this. It is our PHP configuration for FPM. And what we're doing is on line 4, we're setting our user, and on line 5, we're setting our group to specific variables that we've put elsewhere in this playbook. In this particular playbook, those variables are defined in the default/main.yaml file. Like I said, there's lots of different places, and you can very easily confuse yourself on where your variables are coming from with Ansible. You can also add multiple roles to your playbooks. So we're going to add our Ansible role PHP to our install Vim. So now our configure vagrant playbook installs Vim, and it installs and configures our PHP version for us. Now running that is the same. We just run our Ansible playbook. We pass in the same arguments, and now it runs all of our different roles, and we can see that installs Vim ran. It was already installed. It didn't need to do anything. And we can see that this was a subsequent run of this other playbook, the Ansible role PHP, because nothing was actually happening. If this was a blank system, you would see things being yellow there because Ansible was actually taking action. So what does an inventory file look like? This is a dummy setup. None of these hosts work. Don't worry, and feel free to go hack all these IPs if you'd like to. They are free reign. Have fun. But this is what it would look like if you were building out some web server infrastructure with 3 web servers, a load balancer, database server, and maybe a Redis server as your cache. So we could group our web servers under the web server tag, and then we can specify our host names and then our Ansible IPs. And then we do the same thing for a load balancer. And what this grouping allows us to do is we can group plays, our roles and tasks. We can group them to an inventory group so that we only want to install and configure Apache on our web servers. On our load balancer, we want to install and configure HA proxy. On our database server, we want to install Postgres, but we don't want to install Postgres on our web servers or our load balancer or Redis. So we can say, if when the group name of the inventory for this system is web servers, do web server roles or tasks. That allows us to run all of our playbooks and roles against our infrastructure to be able to separate out what we're doing and only run the services we want on the remote systems. Now, you can have more than one inventory file. This inventory file looks very similar to the previous one, but it is a staging environment. You can see that I've got everything prefixed under a staging subdomain, and we're all using different IPs. Feel free to hack these IPs too. Let me know how it goes. Have fun. Dev environment, same thing. You could just have multiple inventory files, and what you do is to run the playbooks on this different inventory file, you just change the inventory file that you passed on the command line. So you run Ansible playbook, and you can do -I and specify whatever your environment is for your inventory for what playbook you want to run. Ansible can also deploy your code. We can use the Git module, and we can pull the repository. We can clone it to a specific destination. We can use a specific branch. What we're doing on line 10 and 11 is we actually have an application user that we want to install the application as. So we will tell Ansible to become a specific user, which will do the SU escaping to run this command as that actual user. We can also tag our tasks, as you can see with a tag called get. That allows us to run a playbook and filter and only run specific tags. If we only wanted to run the get configuration on our server, we could just run the filter with the get tag and it would only fire the tasks that have the get tag. General advice is use environment-based playbooks and inventory files for clear separation and make it easy to handle one-off differences in your server infrastructure. Use Python or some other environment variable system for managing your secrets. This is all infrastructure as code. If you are putting passwords and secrets in a Git repo, you should be encrypting those. There is an Ansible secret system that you can set up that will use and cryptographically encrypt your Ansible variables as they sit in GitHub, but they will be unencrypted on your local system. That is a very important thing to do and is relatively easy to get set up and started with. You can also do system maintenance. We can have apt run only if the update cache has been over 3,600 seconds, so that we're not always running apt get update, which will allow us to run our playbooks faster because we're not waiting on apt to update if it's still within the time period. We can also do a dist upgrade, which is risky, but you only live once. We can install and configure certbot for SSH certificates or SSL certificates, not SSH certificates. We can allow connections through our firewall. We can add users and keep your secrets secret. This is a good article from Red Hat on how to handle secrets in Ansible, whether that is using Ansible secrets and encryption or throwing your secrets out to something like Vault from HashiCorp. That's all I have. I have scratched the surface with Ansible here. If you have any questions, let me know. If you want to know more about Ansible, check out Jeff Gerling's guide, DevOps with Ansible, or Ansible for DevOps.
Wow, that was dense.
It's hard to do Ansible, and that was, let me see what my timer says. That was 18 minutes.
Wow.
And I didn't even get into variable precedence. I didn't even show you some of the locations we could put variables. So yeah, there is a ton of stuff in Ansible.
That was fantastic. And point of reference, I will not be attempting to hack any of those IPs he put up. I think there'll be some nasty secrets.
No, those are all internal IPs. They probably don't even work on your system.
That's what he said. All right, folks, Joe is open for a few questions. If you have them, jump in there. First come, first serve.
My question is, what is the job market like for Ansible?
So if you want to work for a big company, Ansible is at the core heart of Red Hat's enterprise automation system. So if you go to redhat.com and you look at their DevOps pipeline, what they call DevOps and automation pipeline is a shortcut for Ansible and AWX, which AWX is actually a lot of things. It is essentially a Django web application that runs Ansible for you. So think of it as a control node that runs all of your Ansible playbooks. But the amazing thing about AWX is it has an API. So you can actually, what we do at Pretect is we have our AWX instance that runs all of our deployments and configurations for our servers. We have a Hubot chatbot wired up in Slack to where developers can go run their own commands and set up their own systems. And if they need to reset something, or if they see something weird on the CI server, they can run a command and it fires off AWX jobs from our Hubot JavaScript bot. And those jobs could be anything. They could be anything from copying a database export from a production environment to processing data from our machine learning pipeline, or getting really any information off of any of our systems. We have several Dockerized container services. So we have a couple of commands that are playbooks that just reach out and run Docker commands to figure out what the current tag or how long a container or service has been running. So we have some of those out there that are just, helper scripts that allow us to look into our infrastructure without having to touch SSH. So for that, I guess the actual question of what's the job market like? The job market is huge out there for DevOps. And ultimately you kind of have to find a shop or know a shop that is using Ansible. But there's also several tools out there that are very similar to Ansible. There's Chef, there is, oh, I'm blanking on it. Progress just bought Chef. The Salt Stack is a thing, and there's a couple others that are very, very similar, but
Is
they are entire
Terraform-
systems. Terraform is not quite like Ansible. It's more of Terraform is more like a I forget the AWS thing. Like if you're in AWS, you use AWS, not Terraform, even though you could use Terraform. CloudFront or something, maybe. I'm blanking on it. I don't do AWS during the day, so I'm kind of sketchy on all of their offerings these days.
Thanks, Joe. Steve, I think I saw a hand raise.
Well, I wanted to say, first of all, anybody that's a working developer, please go ahead of me. But if nobody else has a question, I was actually going to just ask about Terraform. I love DevOps as a philosophy and Gene Kim's books, and I'm mobbing with my DevOps and SRE guys right now on Terraform and just getting started. But I was wondering if you had, I was thinking that they were equivalent things. So the premise of my question may be wrong, but I was going to ask you if you knew anything about the two of them or anything about Terraform, things to look for, warnings, reasons you do or don't like it or whatever. But if that doesn't apply, then
We've played with Terraform a little bit at Pretact. Terraform is essentially when you want to go from absolutely nothing to a full running system. Terraform is what you'd want to reach for. Because Pretact hosts most of our infrastructure in a PaaS, we use DigitalOcean, so it's a platform as a service offering. So I expect the VMs and the nodes that I'm operating on to already exist, whereas Terraform is like, we are going to create everything for you. And we've done some experimentation with Terraform in DigitalOcean, and the only thing that you really have to watch out for is your state. You have to make sure that your centralized state is undisturbed and has really good uptime, because if you can't reach out to your state store, you have no idea what's going to happen. Terraform, the other benefit of Terraform is it can actually provision your servers, and whether that's provisioning using Ansible or Puppet, or that Puppet was the other one I couldn't think of earlier, Puppet or Chef or Salt Stack or Fabric, if you're still dealing with Fabric, you can use those technologies in conjunction with Terraform. So like if you went into a shop and you said, well, we already have Chef that does all of our server configuration stuff, you could say, no problem, we're just going to wire up Terraform to run your Chef code. And that would all work. So Terraform is kind of like the Kickstarter of, you don't have any infrastructure and you're wanting to create it from scratch. That's what you reach for. There's another an AWS specific tool that works better because it's in their infrastructure that I'm blanking on the name. That's what you would reach for in AWS, but just because AWS has special tooling, because they are their own special snowflake.
all I know about what's under the hood is we're all Azure and Terraform and SonarQube. That's about as much as I know right now.
Are you actually doing anything actionable with SonarQube?
I couldn't tell you because
Okay.
I mean, literally yesterday was the first day that I got on with the other two guys.
Gotcha.
Two out of I got 5 guys that are DevOps and SRE guys. And
I've only ever seen SonarQube in action in 2 different jobs, and I've only ever seen it used actually the way it's intended to be, which is code quality, code metric tool, and static analysis. I've only ever seen it done at one job at AOL. We had it, and holy crap, it was insane. It's like when I left AOL, I missed it because it would do so much stuff. And the other job that I was there, it was one of those things where a developer had it running on a box in his office, so it never really got used. So we were collecting the data, we just were never inspecting the data. And that's one of those things where if you're going to collect the metrics, go read the metrics, go look at it.
Yeah, when you said that, it reminded me, Gary did kind of walk me through, just showing me what was in there, and it shows you like code smells and patterns and things to watch out for. Yeah, he did say most of the developers just wave their hands and say that doesn't matter, which immediately gave me a okay.
A lot of times you'll see that when there's not an established coding standard or linter in a project, and it's just because people don't care because they're just used to that format.
Right.
You'll see that less in projects that are really strict formatting and linting.
We have another tool that I don't know if you'd call it a linter, but it is a checker of a type, and I think it does some of those things, as well as enforces a lot of corporate policies about where things start in ADO and what kind of process they go through and everything. So we have to get like certified with this particular thing that's an internal checker. And so it may be that they're relying on that to some degree and not this.
Yeah, compliance is another big part of what SonarQube can do. And it really is. So if you've never heard of SonarQube, it is a quality control package that what you do is you essentially spin up all these services, you feed your Git repos into it, and it tells you how terrible your code is. It's a service I also offer for much cheaper, but my rates are still kind of high to tell you your code's terrible.
I can tell you your code's terrible for free.
I mean,
on a daily basis, right? A small nominal fee. I see a hand raised from Walker Lowry, the ultimate Memphis Tiger fan. This will be our last question of the night. Walker, jump in there.
Howdy. I don't know if this will be in the realm, but I guess it's I guess it may be next to it. So have you done anything with network infrastructure as a code using tools like this? So I work with like Cisco Meraki equipment. I don't know if you've ever heard of that, but they have like their digital firewalls, digital things like that, but then they also have the physical, but they're getting into more it can be more DevOpsy to deploy those machines. So is anything like this applicable to that? Would you have any resources to get closer to that?
It really depends. So the trick with Ansible is it's SSH based. So anything that is SSH and has Python 3 on the remote end and is a POSIX Unix or POSIX Linux operating system under the hood should be able to do so. You should be able to at least connect and do stuff like who to report the current user, an IP ADDR to figure out the IP addresses, that sort of thing. And then from there, it would just be dependent on either you writing the commands to do the things that you would do when you were normally SSH into the switch or the device, or it would be finding a Ansible module that somebody has written to do that for you and to where you can just write the high level YAML and somebody else has written the Python for you. Or if you wanted to, you could go write that Python module. I mean, Ansible is all open source. There's a fantastic community around it if you want to get started in something like that. I don't know anything specifically. It has been at least 10 years since I've hacked onto a Cisco router. And at that time it was their operating system. Cisco, is it iOS? Was that what it was? Or yeah, iOS is. Yeah, I took a couple of hacking classes back in the day, and we did some hacking events on exploiting iOS and some of those things. But if it has if it's SSH-able, if you can get to it through SSH, Ansible is an option. It's just a matter of, does the embedded OS running on those network devices actually support enough of a Linux system to get by?
Okay, so yeah, their main language and main SDK is like Python. So, and I know they have at least their virtual offering. Cisco offers their, I guess the move is to more, less of getting into the physical hardware and more like you're delivering commands. So I guess if it does have a server, which that's how it would be deployed. So that's cool. Thank you.
Yeah, no problem. That's the great thing about Ansible is you can do so many things that you wouldn't normally think of. Like I'm currently working on a very generic set of playbooks to build my dev environment. So I use WSL on Windows 11. So I have my Linux operating system runs in a small container, and I like to hop around to different distributions. And what I want is a playbook that will set up my SSH keys, my encryption, all my private settings and stuff. I want to set all that up automatically. So that's kind of what I'm working on my own, just to try to make that aspect of it easier on myself. But there's just so many different things you can do with it. Yeah, all you need is an SSH connection and a few other things. So I would definitely test it out and see, and Google Ansible and see if there's a module out there for it. I mean, there's possibly somebody who's already working on it.
Cool, I will do that now.
There's one additional question that popped up in the chat. Joe, would you honor us with
Sure.
one final question? And Chris,
so
verbalize that, or you can read it, Joe, either way.
Yeah, after initial setup of a server, do you still need Ansible on that server? What am I getting at? What I'm getting at is I need to set up 30 Linux servers with 50 to 100 commands on each. Would this be a tool to reach for? 100%, yes, it is. And there is nothing to uninstall for Ansible because there is no agent. everything is handled over SSH, and all of the logic is calculated on the control node, which is the node that you are running Ansible from. So in my examples, it was my computer I was running Ansible from. So that was the control node. So everything was all of the logic was happening on my system, but all of the fetching of the data was happening over SSH. So if you had 30 servers and you wanted to set them all up with specific, and they were all going to be application servers, and they all were going to get Python, and they were going to get maybe a Flask app installed, Ansible is 100% what I would reach for, because that is exactly what it's designed to do. And you could actually tell Ansible to run the playbook against only a section of those servers as well, or you could tell Ansible to run all of those servers at one time. You could have it set up to where you run 5 at a time and run in parallel, or you could run them sequentially. There's all different kinds of execution modes you can do as well in order to speed up how long you're actually taking to provision. But once you're done and the systems are out there, you can, I mean, if you want to remove any trace of Ansible, you just change the SSH keys.
Cool. Got a thanks. All right. Well, folks, that's a wrap. Thank you so much for coming out to the Code Connector May, whatever the day is, 4th Tuesday, May meetup. This has been a lot of fun. Thanks to our speakers, to Joe, to Brett, to Steve. Awesome information as always. This will be on our YouTube channel, our small fledgling YouTube channel, but it's packed full of great information. Glad you guys came out. A couple of reminders for you. Down in the chat, JC has already mentioned our next meetup is actually this Friday around lunchtime for our UX UI focus meetup. Coriano, who you see in the group here, he's one of the leaders for that meetup. Looking forward, June 14th will be our next coding dojo, where we do the lovely, fun whiteboard style interview questions. So definitely want to be there for that. But before that, this is a huge one, June the 9th, for all of you who are in the Memphis area. Some of the leaders of Code Connector, we are partnering with Google developer groups, and we're doing our first in-person meetup in forever, 2.25 years. So just look up Code Connector or GDG. There'll be interview prep, there'll be resume reviews, and I'm sure lots of motivating words by the one and only Danny Thompson. So you don't want to miss that if you're in the Memphis area. And even if you already have a job and you're a senior, you don't need that stuff. Hey, just come volunteer, just come hang out with us. I'm sure there'll be pizza and drinks and things like that. Beyond that, y'all have a great night. Thanks again for showing up, and we'll talk to you next time.